to True Projects. In this video, we are going to explain about the project, which is Intelligent Framework for Detecting Predatory Publishing Venues. Introduction of the project. The project acknowledges the cumulative nature of scientific progress through scholarly publishing. Scientists contribute to the collective knowledge by publishing their research, impacting diverse realms such as politics, society, economy, and health. Emphasis is placed on the critical importance of maintaining the integrity, quality, and evidence-based practices in scientific research. The project highlights the multi-phase risk with a particular focus on predatory publishing as a major threat. Predatory publishers are recognized for damaging science by allowing questionable content to be published without robust peer review. The project defines predatory publishing venues as entities that publish scholarly content of questionable quality for profit, lacking transparency in their policies. These venues deceive stakeholders including authors, readers, funders, and editorial board members. The scale of predatory publishing is underscored by statistics indicating a significant increase in published articles over the years. The project underscores the gravity of the issue by highlighting its impact on researchers, financial resources, and even patient safety in biomedical fields. The escalation of the predatory practices is presented as a pressing concern that require effective solutions. The main goal of the project is to address predatory publishing by proposing an intelligent framework. This framework aims to automatically identify whether a journal is predatory or not, providing clear results. The project explores both machine learning and deep learning approaches and aims to compare their effectiveness. Key objectives include proposing a framework, creating a dataset, and evaluating the framework's performance. Objective of the project. The primary goal is to develop an intelligent framework that is capable of automatically discerning whether a journal's website is predatory or legitimate, addressing the pervasive issue of questionable publishing practices. The project aims to assess and compare the efficiency of machine learning and deep learning methods in detecting predatory venues, providing insights into the most effective technological approach for addressing this challenge. A key objective is to create a comprehensive and automated framework that can reliably identify predatory publishing venues, contributing to the enhancement of the overall quality and transparency of the scholarly publishing. The overarching goal is to rigorously evaluate the effectiveness of the proposed framework through case studies employing key metrics such as precision, recall, and F-score to measure its accuracy and reliability to detect predatory publishing venues. We need software and hardware requirements to implement this project. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. Essential Python libraries and packages are imported in this step. We have imported NumPy for numerical operations, Pandas for data manipulation, Seaborn and Matplotlib for visualization, sklearn for machine learning, Keras for deep learning, and NLTK for natural language processing. Exploring the dataset. The dataset containing information about predatory and legitimate publishing venues are analyzed. Here we understand the structure and characteristics of the data, providing insights for subsequent processing and model training. Text vectorization. Here we convert textual data into numerical vectors using technique TF-IDF. In TF-IDF, term frequencies within a document are calculated, highlighting the importance of words in specific context. The inverse document frequency penalizes common words and emphasizes rare ones, providing a measure for term significance across the entire dataset. This TF-IDF score is then used to represent documents as numerical vectors, aiding machine learning models in understanding and analyzing textual data as applied in this project to identify predatory publishing venues. Data processing. Here we have substeps which are shuffling. Here we randomly reorganize the dataset. Coming to normalization, we adjust the data to a common scale for consistent model training. We enhance model training by ensuring randomness and uniformity in the dataset. The next step is splitting the data into train and test. Here we divide the data into two subsets, one for training the model and other for testing the performance. Here we assess the model's ability to generalize new unseen data. The next step is building the model. Here we define the architecture and specifications of the machine learning model. We establish a framework for model to learn patterns and relationships within the data. The next step is training the model. The model is fed with the training dataset to learn patterns through iterative adjustments of parameters. Here we enable model to make accurate predictions by learning from the labeled data. Flash framework with SQLite for sign-up and sign-in. Here we implement a web framework which is Flash with a database called SQLite for user registration and authentication. We allow users to sign up and sign in and interact with the application. The next step is user input. Here, users provide input which are related to identifying predatory publishing venues, which are PDFs of the journals. Here we enable users to utilize the model for prediction based on their specific inputs. Pre-processing the input. The input from the user is pre-processed to confirm the requirements of the trained model. We ensure that user input is appropriately formatted for prediction by the model. The next step is trained model is used for predicting the result. The pre-processed user input is fed into the trained machine learning model, and we utilize learned patterns from the training phase to predict whether the input corresponds to a predatory publishing venue. The last step is displaying the algorithms which are used in this project are Convolutional Neural Network, which is CNN. It is a deep learning model specifically designed for processing grid-like data, utilizing convolutional layers to automatically learn hierarchical features from the input, commonly applied in image and pattern recognition tasks. In this project, CNNs are employed to analyze and recognize intricate patterns within textual data, making them well suited for identifying complex features associated with predatory publishing venues. The next algorithm, neural network, which is multi-layer perceptron. Multi-layer perceptron is a class of artificial neural network with interconnected layers of nodes capable of learning complex relationships within data through forward and backward propagation of information. It is chosen for their ability in capturing nonce relationships, making them effective in discerning between predatory and legitimate publishing venues based on learned patterns in the project. The next algorithm is K-nearest neighbor, which is KNN. It is a simple instance-based learning algorithm that classifies an object based on majority vote of its K-nearest neighbors in feature space. While conceptually straightforward, KNN is less effective in this project due to the intricate nature of predatory venue detection, where more sophisticated algorithms are required to grasp complex patterns in the data. The next algorithm is Support Vector Machine. It is a supervised learning algorithm that classifies data by finding an optimal hyperplane to separate different classes in a feature space. SVMs are well suited for binary classification tasks, making them suitable for distinguishing between predatory and non-predatory publishing venues in the project, where the primary aim is to automatically identify based on learned patterns. As an extension, we have employed Ensemble model for improving the accuracy and for final prediction. Also, we have used Flash framework for user testing and the authentication. We have evaluated this project using different error metrics, which are accuracy, precision, recall, and F-score. Here we have accuracy comparison graph. It represents the overall correctness of the model in identifying predatory publishing venues, measuring the proportion of correctly identified instances among the total instances in the dataset. This is the precision comparison graph. It measures the model's ability to avoid false positives, calculating the ratio of correctly identified predatory venues to the total number of venues identified as predatory. This is the recall comparison graph. It gauges the model's ability to identify all instances of predatory venues, representing the ratio of correctly identified predatory venues to the total number of actual predatory venues in the dataset. This is the F1 score. It offers a balanced measure of model's performance by considering both false positives and false negatives, serving as the harmonic mean of precision and recall in identifying predatory publishing venues. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the dataset folder in which we have legitimate journals and predatory journals. We use this dataset for training the model. This is the static folder, which consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model folder which contains algorithm information and that will be loaded into the project code during runtime. This is the IPYNB file. This is the Jupyter Notebook file which contains combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign up file. This file is the database file used to store the user information. Now to execute the project, first we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py and click on enter. This will compile app.py file and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. This is the localhost and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. I've copied it. Here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First we need to click on it and enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so we'll directly click on login. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. And now we need to click on submit. We have logged in successfully. Here we can see a choose file button. First we need to click on that to upload the journals. So I'm clicking on choose file button. I'm selecting the first PDF, which is journal, and click on open and click on upload. Based on the provided journal, it has predicted as the journal is predatory. Predatory is a category that typically includes journals which engage in deceptive practices, publishing low quality or questionable research without a proper peer review, often for profit. Now we will click on try again and upload other journal and see what will be predicted. Click on choose file again. I'm selecting the last journal, click on open and click on upload. Based on the given journal, it has predicted as the journal is legitimate. Legitimate refers to adhere to ethical and rigorous standards of peer review, publishing high quality and credible research. Now we will upload one more journal and see what will be predicted. Click on choose file. I'm selecting the third PDF, click on open, click on upload. Here it has predicted as the journal is predatory. Now we will upload one more PDF and see what will be predicted. Click on choose file. I'm selecting the last second PDF, click on open and click on upload. Here it has predicted as the journal is legitimate. In this way, if we give the journals and the PDFs to the system will predict whether the journal is legitimate or predatory. Click on sign out. Conclusion of the project. The project has successfully created an intelligent framework employing artificial intelligence techniques to identify predatory publishing venues, contributing to the improvement of overall integrity and quality of scholarly publishing. A comprehensive dataset annotated for predatory and legitimate journals are established. The framework effectively employed various machine learning and deep learning models for classification, showcasing a multi-phased approach for predatory venue detection. The framework demonstrated strong performance, achieving higher accuracy, precision, recall, and F-score in journal classification across all models except KNN, underscoring its potential as an effective tool in identifying predatory publishing venues. The framework's evaluation emphasized its effectiveness in automatically detecting predatory venues and violations. This tool serves as a valuable resource for researchers, students, and readers, aiding in the identification and avoidance of predatory publishing when used in scholarly research.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.